Making a two-way frequency table of rows or columns. So complete the two-way frequency. This conditional relative frequency shows the information in example 2. Pick the frequency to interpret. This table is commonly referred to as relative frequency of the rows. So let's see here. So 94 out of the 100 parents with one kid were saving. 6 out of the 100 parents with one kid were not saving, and then 100 out of the 100 parents that we talked to with one kid were parents with one kid. So the families with more than one kid, that was 60, 26, and 86. So the total is the 86 out of the 86 parents we spoke to were the parents that we spoke to with more than one kid. 60 out of the 86 were saving. And 60 out of 86, that should reduce. 30 over 43, yeah. 30 out of 43, which is about 69.8%. I'll put those in for that because they want me to. And then the total who were not saving, was it 26? Yeah, 26. 26 out of the 86 were not saving, if we reduce that. Yes, I know, I would love to divide out those sixes, but that's just not how it works, folks. I'm so sorry. 13 out of 43 are not saving. So 13 out of 43, about 30.2%, or about 0.302. That makes me happy because those both add up to 1. And then your totals, remember, so of the savings, there was 154 saying they were saving, 32 that said no, and 186 total. So the total was 186 out of 186 are humans that we spoke to, or families that we spoke to. And there were 154 people who were saving. 154 out of the 186 people, and 154 out of 186. Oh, we already did this. We already did this part. Is 77/93. And fine, that's about 0.828%. 0.828. And then the other one is the rest of them, which again, we just did up here. 32 out of 186, which is 16/93. We already did that. 16/93, which is about 17.2%. 0.172. Now we're going to do the same thing, except now we're going to go by column. So 94 out of the 154 people who were saving were families with one kid. 60 out of the 154 who were saving were families with two kids. So up here we're going to go. Let's see. The people who weren't saving, there were 32, 6, and 26. So 32 were not saving. And by the way, that's 32 out of the 32 people is 1. 100% of the people who were not saving were not saving. Now 6 out of the 32, which I can actually reduce just fine, but I'll put that over here. Divide by 2, which is 3 over 16. This isn't a horrible number. Well, it's not that great, but 0.1875. That is about 18.75% of the people who aren't saving are families with one kid. Now over here, the rest of them were these guys, which I've already forgotten the number. Is it 26? It is 26 of the people who are not saving were families with more than one kid. 26 over 32, reduce that by 2, and that's 13 over 16. And 13 over 16, while not terribly nice, isn't the worst thing in the world. 81.25%, 0.8125. Now the total is, again, 186 out of the 186 people we talked to were people that we talked to, or families that we talked to, so that's a 1. And we actually did this already up here. 50 out of 93, or excuse me, 100 out of 186 and 86 out of 186. which is 50 and 43 out of 93. So this was 50 out of 93, and this was 43 out of 93. We already did that in a previous section. And 50 over 93 is about 0.538. About 53.8% of the people we talked to are families with one kid. And 43 over 93 is about 46.2%, 0.462. So that was just doing it by column instead of row. Finding conditional probabilities from a relative two-way frequency table. For financial reasons, the school district is debating about eliminating a computer programming class at the high school. The district surveyed parents, students, and teachers. The results given as a joint relative frequencies are shown in the two-way table. Okay, so what is the probability that a random selected parent voted to eliminate the class? So here's all the parents. There's the secret total that I wish I had, which, well, let's go ahead and just do this. So for the parents, what's the probability the randomly selected parent voted to eliminate the class? Well, we can take the probability of your parent who voted to eliminate 0.58. Oh, yeah, I'm going to go ahead and assume that yes means get rid of it and no means let it stay. So 0.58 over 0.58 plus 0.06 equals 0.58 over 0.58 equals 0.06, 0.64. And if you divide those, I get 0.90625, which is 90.625%. That is, 90.625% of parents said, get rid of that class. It's dumb. The homework's long. Mr. P teaches it, and he's terrible. Yes, so that's what they're saying there. What's the probability that a randomly selected student did not want to eliminate the class? So again, how many didn't? 0.15? So 0.15 of the people were students who didn't want to eliminate the class. And we're going to divide that by the total number, well, total probabilities associated with students. So 0.15 plus 0.08. 0.15 plus 0.08 is 0.23. So 0.15 out of 0.23. We're going to have to approximate that, people, because it's not going to be nice. I can tell you that right now. About 0.652, or about 65.2% of students said Mr. P's class is awesome. His voice is really annoying, but once you get used to it, it's not that big of a deal, and so on. What's the probability that a person who said yes is a teacher? Well, the teachers who said yes were, look at that, way more teachers voted to say get rid of that class. You guys, don't even worry. They didn't back me up at all. So 0.1 is the number of teachers, the percentage of total people who were teachers who said, get rid of that dumb class. We don't like Mr. P. He's always letting his snake into the faculty room. I'm just kidding, guys. I don't actually own a snake. Or maybe I do. Okay, fine. I actually don't. No, okay, yes, I do. Actually, no, I don't. I don't actually own a snake. Unless I do. But I don't. I actually do. 0.58 plus 0.08 plus 0.1 is 0.76, so I get 0.1 over 0.76. So the probability that somebody who said, yes, get rid of it, was a teacher, we're going to go ahead and do 0.1 divided by 0.76 is about 0.132. That is, about 13.2% of the people who said, eliminate that dumb class and get Mr. P and his snake and his lizard out of my school, were about 13.2% of those people were teachers. I don't actually own a lizard. Okay, maybe I do. Or a snake. Anyway, that's it, folks. We made it. Congratulations to those of you who are not moving on to the honors section. I just want to say one more time that it has been an absolute pleasure being your instructor. If you have any specific questions about this section or anything else, please send a message to your online instructor. And until we see you again in another section, or perhaps on in the honors, have a wonderful rest of your day.